So in addition to talking about water in this lecture, we also are going to talk a little bit about the pH scale, which is a numerical scale that we use to indicate how acidic or basic a solution is. And so you can see distilled water here on this picture of the pH scale at pH 7. And the values of the pH scale range from 0 at the bottom to 14 at the top. And 7, where distilled water is considered neutral on the pH scale. So water is relatively neutral in pH. It's not really acidic or basic, it's perfectly in the middle. Anything below 7, from 0 all the way up to 7, is considered acidic. You can see lemon juice, orange juice, coffee down here. And anything above 7 on the pH scale, from 7 to 14, is considered basic. And what's important to remember about the pH scale is that it's not like a linear scale, where moving from pH 7 to pH 8 would indicate basically a doubling or a 1 times increase in the basicness or the alkalinity of a solution. It's a logarithmic scale, and that means that every time you move up 1 unit in pH or move down 1 unit, each change represents actually a 10-fold change. So if you're moving from 7 to 8, you're actually increasing, 8 is actually 10 times more basic than pH 7, and 6 is 10 times more acidic rather than 1 times, right? And so that would mean that when we think about lemon juice down here, it's 1, 2, 3, 4, 5. It's 10 to the 5 times more acidic than water, which is really, really acidic. And we have ammonia up here, which is 10 to the 4 times more basic than water, because each change of 1 unit represents a 10-fold or a 10 times change. And so I want you to take a second, look at this pH scale here, and just based on the numbers, determine if you think black coffee is acidic or basic. Pause the video, take a second. Black coffee is down here at pH 5, and since that is below 7, coffee would be considered acidic on the pH scale. And so this one is a little bit more difficult. Take a minute, pause the video, and work through these answers to figure out which of these statements is true regarding black coffee and lemon juice. Okay, so first we have to determine if black coffee is more acidic or more basic than lemon juice. And black coffee is here at pH 5, lemon juice is here at pH 2. And so since black coffee has a higher number on the pH scale, it would be considered more basic than lemon juice, or more alkaline. So we can eliminate A and B as choices, right? Because black coffee is more basic than lemon juice. And then because the pH scale is logarithmic and not linear, each of these changes from pH 5 to pH 2 is a 10-fold change in how much more basic black coffee is than lemon juice. So pH 3 would be 10 times more basic, 4 would be 100 times more basic, and black coffee here at pH 5 is 1,000 times more basic than lemon juice. And there are some types of substances or chemicals that actually are able to resist changes to their pH and stop those fluctuations from happening to keep pH within a normal limits. And those are what are known as buffers. Right? And so the health of organisms, including us as humans, requires that we maintain pH of body fluids within a very narrow limit to maintain homeostasis. And so human blood normally has a pH of 7.4, which means it's slightly basic. It's a little bit higher than that neutral point of 7. And if blood pH drops below 7, so just a 0.4 change down in the pH scale, a condition named acidosis will result. And the same is true if it rises just 0.4 to 7.8. You'll undergo this state called alkalosis. And both acidosis and alkalosis of your blood are life-threatening. And so human blood has to retain this perfect pH balance at 7.4. And therefore, blood is buffered to prevent pH changes. You can add a lot of acidic compounds, a lot of basic compounds, but blood is able to actually resist changes to pH in order to keep us alive and healthy. And so, to summarize what we've talked about in the water lectures, as well as the pH one, we need water, right? Human body is 70% water. We need it for a lot of different processes, including maintenance of homeostasis. And water is able to become so essential and be life-sustaining because of its chemistry. And it has particular properties because of that chemistry, such as the ability to stabilize temperatures, the ability to dissolve solutions, as well as the ability to stick to itself and other molecules to basically make it a good means of transport in organisms and also help sustain life in organisms and on the earth. Water itself is neutral according to the pH scale, so it's at pH 7. And anything on the pH scale below 7 would be considered an acid. pH above 7 are considered bases. And so all of these things, water as well as the pH scale, acidic and basic, are things that we're going to continue to talk about in the next couple lectures about macromolecules as well as about the structure of cells and organisms.